We would like to welcome Balvinder and Pranesh. Balvinder ma'am works as a technology principal at ThoughtWorks, and Pranesh is working as a senior consultant for ThoughtWorks. Balvinder and Pranesh would be speaking on QA and Agile on big data projects. To know more about Balvinder and Pranesh and to see their video interviews, please check out the links below. The floor is all yours, sir and ma'am. Thanks so much.
Thanks, Shivam, for introducing us. And thanks, everyone, for coming to the conference and spending your Saturday afternoon with us. We hope we make good use of your time. I'll quickly start sharing my screen, and do let me know when you see it. Is the screen visible?
Yeah, I can see it.
Good. So let's get started. So what is all the fuss about? Why we are here and what are we going to talk about? Last decade was full of digital transformation for enterprises. So all the enterprises, modern enterprises, went through this digital transformation journey, and they developed a lot of digital platforms to convert their customer journeys into digital journeys. These digital platforms helped the businesses to collect a lot of data. They were collecting data at an unprecedented scale and an unprecedented detail. What do they do with this data? So they had data platforms to convert this data into actionable insights. And then they were feeding the insights back into the business process, into the digital platforms to make it even better. All of these digital platforms have very sound quality assurance processes, as well as they use agile practices for a faster delivery. What happens when it comes to data platforms? For the data platforms, we need to modify and adapt the agile practices as well as quality assurance practices. And then they help us to evolve the data platform as good as they help us to evolve our digital platforms. So that is what we are going to talk about today. So today we will discuss how in the projects that we have worked on, Pranesh and I both, our experience on working in these big data projects, what are the changes that were required in the agile practices, the changes required in quality assurance practices, the tools and the tech stack that we use. And we will do this based on one case study. We will talk about it more in coming slides. I think Shivam has given a lot of introduction for us, but before we move ahead, a little bit about ourselves. Pranesh?
Yeah, I'm Pranesh. I'm associated with ThoughtWorks as a senior consultant, quality analyst. I'm having around 10 years of experience in a QA field, and I'm a strong advocate for the shift-left approach for the testing lifecycle.
Thanks, Pranesh. And this is Balvinder. I have around 16 years of industry experience, and I'm currently working as data strategist with ThoughtWorks. In my role, I work with clients to help them build their data strategy, to figure out data architectures and data platforms, and get the value out of data for their business. And currently, I'm also leading the global data community for ThoughtWorks. So moving ahead, as I said, we will talk about our experience and a case study. So this case study is for an international retailer. The retailer is based out of Europe, but they have stores across the entire globe, and they also have online presence. Just like I said, they had collected a lot of data. They had a lot of digital platforms on which customers were coming and interacting and generating a lot of data as a byproduct. They wanted to utilize this data to have a hyper-personalized solution on pricing, which meant generate the prices for all the articles that they were selling so that they are serving the customers with the right price at a right place and a right time, which means depending on who is buying the product, from where they are buying it. Are they buying it from a physical store, or they are going into an online store and buying it? At what time are they buying it? Are they buying this over the weekend, or they are buying the products on the weekday? The prices that would be served to the customers would be different. And it would be the prices which would be most appealing for the customer because it is personalized. And as a result, what would happen is their sales would go up, they would increase the profitability. And all of this is based intelligently on data and a lot of internal and external factors, which means data is also collected outside of the organization. Breaking it down further and looking at it from someone who is inside the system, we talk about Sally. Sally is a price analyst working with the client. So when I say price analyst, in her role, Sally has to review the prices of the products, various products that she is responsible for, analyze the changes in the prices over the past few years, and also analyze the product performance. So when the price was changed, how did the product sales perform, or what was the demand of the product? And on the basis of this analysis, she would recommend new prices for these products and also look at the company strategy. So in the pricing world, companies come up with different strategies for pricing of different products. Some of the products, they prices based on competitor. So what is the competitor price? And accordingly, they would price their product in the vicinity of that price. Some of the products are purely for generating profit, so they could be priced a little higher. Some of the products are for generating the footfall of customers. So based on this strategy, she will recommend prices. She would also do a lot of manual data sorting and validation in this process because she has to understand all of the historical data. She would do some mathematical derivation, which is basically extrapolation of historical data to future recommendations. And yes, she's generating a lot of reports in this process for herself, for her supervisors, and she's doing a lot of data curation, cleaning, and filtering for that report. So when we say a hyper-personalized solution for pricing, what does it mean for Sally? For Sally, it means that she wants to get price recommendation automatically generated. So all the manual activities that she's doing, she wants that to be automated, which would reduce a lot of effort and also be more accurate. And then she also wants these prices to be published to stores, whether these are online stores or these are stores in the physical world. And then she wants to continue looking at the buying behavior of the customer. If the prices are incorrect, the buying behavior might change drastically and the company would lose out on profit. So she wants to continue looking at buying behavior and optimize the profits. And then definitely, as we said, she is going to also look at a lot of reports. Translating this vision for the business organization overall and what it meant for Sally into technology, what we are looking at is establishing a framework and culture where data is treated as a first-class citizen. Data is used to make effective decisions across the organization. Doing this means touching all of these different aspects that you see on your screen. So you start with data engineering, which means collecting data from various parts of the organization, from parts outside of the organization, bringing this data together and looking at the picture holistically. Essentially, you want to build scalable infrastructure to handle this data. Once you have all of this data, you want to start looking at the patterns and the trends in this data so that you can use that to predict the future, which is the data science aspect. So you drive your business and user decisions not on any gut feeling, but on what data is telling you. And the ultimate goal or the nirvana is to reach the artificial intelligence stage where your systems would start learning by themselves. They would understand the decisions that were taken in past and the impact of those decisions and course correct their own decisions, which is the artificial intelligence bit of it. And then you see the different skills required in these aspects. So starting from, just give me a moment, starting from software engineering to data engineering, which is data wrangling and machine learning. Let's look at two aspects in a little more detail because that's where our entire data platform is based on. So we have data engineering. As I mentioned, the first step is to collect data from various parts of the organization, which means understanding how the data is flowing, how do we access the data, what are the different interfaces and mechanisms that we need to. Let me know if the screen is visible again.
Yes.
Yeah, so we were talking about data engineering and we were talking about how we need to build systems to collect data, acquire data, do some transformations on top of this data and make this data available for further usage by data scientists, and data scientists would run their magic on this data. Essentially your ETL, which is extract, transform, load, or ELT pipelines in short. The next skill that we need is data science, definitely. As I said, you need to understand what are the stories that data is telling you, discover the hidden patterns in data. This would help you make decisions and predictions, use some causal analytics, prescriptive and predictive analytics. So now let's put all of this, the data engineering, the data science, and different aspects that we have seen back into the problem that we discussed for the retailer. So what we want is prices optimized for profit, let's say, and then we also want to push these prices to the systems which will display it on the online stores or on the physical stores. We also want to create some reports out of these prices. And definitely these prices would be stored somewhere. How do we achieve these optimized prices? We want data magic here. So we have some data science pipelines running over here. In our case, what we used was demand-based pricing. And any algorithm that you would use would have certain requirements of the data that goes as input to this algorithm. In our case, one of the requirements was separating seasonal and non-seasonal products, because different kind of products have different kind of behaviors, and we don't want to skew our result based on these different behaviors. Essentially, what we are trying to say is, before the algorithm, you will have a pre-processing stage so that your input is as per what algorithm needs. And then you also have some post-processing stage. You might have some rules. To do this, I need all of this different data, as I spoke about earlier. So I need prices of all of my articles. I might also need price history of all of my articles. I need sales information of these articles, because I want to establish this relationship between prices and sales and then extrapolate that relationship. I need to work with different reporting systems to push back the reports. I need to work with pricing systems to push back the prices. There could be events as well, which would help in getting data from outside world. And then this data goes through multiple stages here. So you ingest all of this data, the product prices, the sales, etc. You would perform some transformations on data. So in our case, for example, we were aggregating the prices across the stores. I mentioned that this retailer had a lot of stores across the globe. So you do not want to go to the granularity of a store. We were aggregating the prices for a given region. You want to aggregate the sales on a weekly basis, because looking at the price trend for each day was really very granular and was not of a lot of use. And then you were also doing some checks if the prices are valid. You don't want to include invalid sales which might come in due to human entries. We were removing the sales that were return sales, right? So because return sales are not part of actual sales, and hence they would impact my algorithm. If I map all of these stages to data pipeline terminology, which would be generic, not just for this use case, you have inputs, you have ingestion for all of these different input sources, you have transformation. Once you ingest the data, you would do some processing on that data, maybe some cleaning so that you can consume it further. You will run some quality checks based on the use case that you are using this data for. The quality check data is then fed to the data science algorithm or the data science stage, which would itself do some preparation on data, run the actual algorithm, have some results ready with it. Once the results are available with you, you will publish that result. You will publish the result. The results would also be stored because you want to audit and see how your algorithm is performing, and export or put these results on the operational systems, which are then feeding this data back into the digital platforms. So now simplifying this entire pipeline, sources, ingestion, transformation, data quality stage. One thing to call out here is this data quality is different from the quality assurance practices that Pranesh would talk about. This is the data quality stage that runs in the production system on the actual data. The data science section, and publishing and exporting of data.
Right. So looking at our vision to provide the right price to the right customer, we need to break it into some workable chunks, and given that we'll work on the Agile methodology. A typical story cycle, something looks like this, where we start with the iteration planning, where different teams meet, followed by a story kickoff, where devs will walk us through what all changes they're planning to make. Then comes a desk check, where they will showcase the working component, and where QAs will apply certain validations to find the bugs early in the life cycle. And if everything goes well for that particular story, as a QA will provide a sign off, and that story gets deployed to the next stage. Now let's see how this fits on a data project with a problem statement like ours. So we need to consume historical product prices, right, to predict the optimum price. So the scope of this story is actually a huge, since multiple technical tasks are involved. Also, coverage could spill over next cycles. So analyzing and scoping is a tricky part here. Also in the desk checks, as we discussed earlier, we cannot validate with the variety of data, since the product pricing data can be huge. Also, providing sign off from the data scientist perspective is also tricky, since at the beginning or at the initial stages, we will be only consuming the historical data. So the deployment of this functionality will also not provide any value to the customer, right? Moving on to the next. So there had to be lots of analysis before we actually move to the development. And doing analysis and scoping will be challenging, since the data is also huge and the outcome will also be uncertain. So non-deterministic nature here will complicate this further. And doing QAing will also be challenging here. So the signing of the story too, right, will have to take a backseat. So let's see how we can map data engineering and data science terminologies here instead.
Okay, sorry to interrupt, Pranesh. We are, just expedite things. I would just request here. Otherwise we would run out of time.
Sure. So as you can see here, a typical agile methodology would look like in data engineering and data science. So in data engineering, we first do data mapping, where we identify the data sources and the required data to be collected from the sources. So in our case, it will be a historical pricing data. And once we identify all the data sources and required data, the next stage is the data modeling, which focuses on how we do structure and store that data for our use case. Then we move on to acquiring that particular data and validating its quality. Afterwards, for data engineering, we'll transform the acquired data to extract the required attributes, say product prices and product information in our case, and validating the transformed data for the next phase, like the deployment. And in case of data science, we'll first start with the literature review to get more insight on our problem statement, followed by analyzing the data to find any pattern. Then we'll develop the algorithm based on the literature review and the data analysis stage, which will give us the result with the desired accuracy, and we'll also validate those outputs, which we can further deploy to the next stage. So this overall practice changes that we feel when we are dealing with the data projects. So now let's have a deep dive into what all QA activities we have and what all different processes that we can follow. So if you can remember, the first stage in the pipeline was consuming the data from different sources, right? So now let's discuss what all QA activities we can do around this stage. So we need continuous stream of data of events like sales transaction from the point of sale terminals from different stores, historical product prices from the production pricing database, also the competitor data, right, from the external agencies. So we ensured that all the inputs are latest as they are on the production. Since we must test using different set of data, as the algorithm is going to need different types of pricing as input, right? So we also ensure that all these prices are available from their respective sources. The most important attributes of data here is the volume, velocity, variety, and veracity. So veracity is something inherent noise in the data. We can use contract validation tools here like Pact, Postman, if we are consuming data from the multiple upstream API sources, which will enhance the velocity of validation at this stage. Moving to the next stage, which is data ingestion. Based on the data consumption process, whether it's streaming or it's a batch job, we need to do some validations here. Like in streaming jobs, we need to validate the schematic of data, like availability of data exactly once, or at least once, or at most once, basically to avoid the duplicacy. We also validated if products and the respective prices which we consume are stored in the correct underlying storage location. So we validated using HDFS and S3. So if you can recall, we only need historical data, right? So we also validated that we are only consuming data from a range of, let's say, 5 years. And the most important factor to consider here is that the eventual consistency of data is maintained and all the data quality rules are applied properly at this stage. Moving on to the next stage, which is data quality. So once the data is ingested in our system, we ensure that we ensure the data integrity by comparing the product with and their prices with the source data that we consume. We also validated that all the products have their valid prices. There should not be any negative, null, or blank values. We also checked for duplicate or any missing information. So validation of something data schematic plays important role here. So we can do this data quality checks at the different stages in the pipeline. It don't have to be after we ingest data. This can we can place this stage at multiple stages within our pipeline. So for our use case at this stage, we store data in Avro format, which is the binary form. So querying on such data will be painful. There are certain tools which come with that capability like Zeppelin and Spark Shell. So those tools helped us here. Moving on to the next stage, which is the data transformation, which is the most crucial step in our data pipeline. So till last stage, we just validated the data quality of the data we ingested in our source. And data transformation is something on high level, which is talking about the extracting out the necessary attributes from the data set, because we might not be interested in all of the ingested data, right? So we ensured that transform data met our algorithm requirement. So as Balvinder pointed out, we need aggregated prices across the store side. So we made sure that after the transformation, we have those prices correctly. Then we also validated there are no corrupt data into the system after the data transformation rules are applied. We also validated the data integrity at this stage. And we also validated that the data is ready for the next stage, which is to consume by the algorithm. And since the data at this stage will be a structured one, so we can use, we actually used Hive and Presto to do the querying against the database. Moving on to the next stage, which is the data preparation stage. So as part of this, we validated that all data is to be consumed by the algorithm is an expected format. So if you can remember, we had data in Avro format, right, where we consume it first. And our data algorithm expected that data in the CSV format. So we validated that the all the necessary data is available in the CSV format. We also validated that the data modeling parameters are available. Also, we ensured that the data ingested has all outliers removed. So outliers are nothing but for our case, it will be a price of any product way off than its average maintained price. And since outlier tends to interfere with the predictions that were intended out of the stage, so such outliers should be removed before we can feed data to the algorithm. We also validated that mean deviation arises are within the threshold limits. Mean deviation, this threshold limits were predefined, and any mean deviation outside this threshold limit should be ignored by the algorithm. So we actually did this validation by manually navigating through the data. We also had some automated script. Even the Jupyter notebook helped here. Talking about the next step, which is data algorithm. So in order to algorithm to run, we make sure that all the preconditions were met. So one of the preconditions as Balvinder already pointed out, that there should be pricing and demand relationship that should exhibit, right? And in absence of that, our algorithm cannot be executed. Also, this information can also be provided by modeling parameters we just discussed in the previous stage. We also validated the efficiency of the algorithm to run, and we also validated that the failing condition fails the algorithm and next subsequent steps did not execute, and any call to action also get triggers. And in case of positive condition, the algorithm is executed, we got our results, and next steps in the pipeline are also executed. Moving on to the next, which is algorithm results. So usually when the final price recommendations were generated, there's also a error generated for every product. Now these errors were expected to be at within a defined range, and this range was pre-communicated because it was understood that no data algorithm can give 100% of accurate values, giving the 100% of confidence. Therefore, in testing, we also validated that the errors are giving we don't have high number of errors and low confidence, and in such case where we have high errors, alert should get generated for the respected team. We validated that the inputs are available in the expected consumable format depending on their next use case. It can be Excel or CSV file if you want to share with any stakeholders. The most important thing here, we validated that every error generated as output, we also consider that error as an input for the next consecutive run to increase the accuracy and gain some more confidence in the consecutive runs. Talking about the next stage, which is a data storage check. So we did regularly at different stages. For example, when we talked about data transformation, right? So this data had to be made available at a particular location so that the next stage, which was the data preparation, can use it. So the main thing that we need to test here is to validate if the data is present at particular location and no corrupt data is into the system. We can also do data integrity checks. Talking about the next step, which is data export and publish. So this is kind of the last stage in our data pipeline where we export the data or export the files for any further usage or the sharing. So we validated that all files generated are stored at the expected location. If any stage needs any process data, we validated that such data is available in the intended location and in the correct format. So for example, some stakeholders might be interested in visualizing some data, right? So let's say how many products we process, time taken by each batch to run, right? The failed jobs, past jobs. So we use a tool here called Superset, and that gives that also helped in the testing. Apart from the stages mentioned in the data pipeline earlier, we also feel there could be some more validation checks we can apply further to our data pipeline. One of that was workflow management. We had multiple jobs, right? Like consumer, transformer. Are those jobs scheduling on time? Are those jobs completing on time? So we on high level, we also validated the time taken by each job. So this is also an important check, and we use tools like Airflow and Yarn, which are the workflow management tools. Next is validating how pipeline behaves when it encounters a huge data, right? This is the most important step or the check we can say. So we validated if system encountered when system encountered a huge data, is my system is able to consume that data efficiently or not? Is there overlap between two subsequent jobs or not when it deals with the huge data? Also, the huge data is able to, system is able to store that huge data into underlying system with ease. And we are also applying the transformation rules. Data processing time is not huge, and there is no pain in visualization, visualizing that data in memory, and resource utilization for our jobs are also within the threshold value. Another form of testing we thought of is the recovery test for jobs, like how system recovered when in case of any failure. So let's say any job failed, what happens when the next job runs, right? Those kind of validations we covered as part of recovery test. We also ensured that if there any node failure, our other nodes are capable of sharing the loads, so that our process of data analysis is still intact. The next important aspect that we covered as part of this is a logging mechanism at the different stages. Is my system able to log, and are we getting more insights for the failures and reasons or not? The last testing step that we feel is health of the environment, but this should not be validated at each iteration. So this checks we can done with some time interval, like checking if environment is having enough storage capacity and cluster with the distributed nodes or not. So just to summarize with the QA activities that just we talked about, they are not as same as the traditional activities that we follow in a normal project, but the approach for testing remains the same, that is challenge the business logic to make it more robust, and the one which gives us the confidence. This QA activities may differ on the other data projects.
So we will quickly wrap it up with some.
Yes, Balvinder,
Yeah.
thanks for pitching in.
Just 2 minutes. We'll quickly wrap it up with challenges and learnings, because no project is complete without some of the learnings, and definitely you face challenges. So for any data project, you definitely need additional skills for the QAs as well. We want to test the data platform, so you need skills to test data on HDFS, S3, or any other distributed storage, where you cannot use your traditional SQL. So you need skills to run Spark code, running the code on notebooks like Zeppelin and Jupyter. End-to-end automation on data pipelines is hard to achieve. So unlike traditional software applications where you have a testing pyramid and you can also do an end-to-end automation, the tools that are available in market are not fit or do not align themselves naturally to data products. So there is a lot of custom effort that is required to create end-to-end data pipelines, end-to-end quality pipelines for data pipelines. You definitely need to adapt the QA processes. You do not have very specific set of rules to test the data platform. You have to understand how data is behaving and then adapt the expectations out of the data. And synthetic data generation, since we are dealing with huge volume, and these volumes could create a lot of edge scenarios which you cannot predict via doing some manual data entry or manually testing the systems. So you need tools to generate this data synthetically, but still within the given business ranges. Some of the learnings that we have taken from this use case and also other projects of data that we have worked on: data quality and its measures is defined by the end result. In this example, we always talked about why we were performing a particular quality check, because this is how it was going to be used in the pricing algorithm. So if your use case changes, your data quality measures would also change. QA is not always on the end result, so we cannot just test the prices recommended and say that the system is working perfectly. We always have to test every stage, as Pranesh talked about it in detail, and we keep shifting our quality to the left. Scope management is a challenge. We talked about it. With data comes all of the different combinations, and you have to manage that scope somehow and find out confidence by testing some area and extrapolating that confidence to other areas. You have to always consider the volume, variety, velocity, and veracity of data. Validating the output with the subject matter experts. This is extremely important because we are dealing with different domains, and the meaning and semantics of data would change with the domain. So we need to validate our output with the subject matter experts. And last but not least, good friendships with data scientists. I think this is applicable for all the projects, but especially in data project, you have to avoid the silos between different roles in the team. Data science is unpredictable, as Pranesh mentioned. It is non-deterministic in nature, and to be able to certify the quality of such systems, you need to understand the data, the domain, as well as the science behind it. So you need to have good relationship with data scientists and be involved with them from start to the end of the life cycle. And that's about us. Any questions? I don't know if we have time. Otherwise, we can also answer on chat.
Okay, yeah, that would be nice actually. And thanks, Balvinder, Pranesh, for your valuable time. So, folks,